So you can see that I'm using fat mode, which doesn't mean that the sound is fat now, it just means that it's oversampling the signal. So in this case, this equalizer is working at 176.4 kilohertz because the original signal is 88.2, and we use it in linear phase mode, and the filter is 24 dBs per octave, and the resolution of the equalizer is at its maximum. So it really has also huge latency, but it's compensated on the logic channel bus. The next thing that I will use is PX equal, and I will start equalizing only mid portion of a signal in isolation, meaning that I will solo the mid and I will try to cut the frequencies in cut mode. I never boost and look for the right frequency and then reduce it. Why not? This is a technique which is good for learning where there could be a problematic frequency, but one problem is as soon as you boost and you sweep the band, you will also change the upper harmonics. So the whole sound won't change only on the frequency region that you are searching for problematic frequency, but you will be also boosting the upper harmonics, therefore your decision will be wrong. Because you will find a spot which will also affect the upper harmonics, and you will say, okay, this sounds best, and you will go into a cut mode. But you were hearing the wrong info, because as soon as you boost all the upper harmonics. So when you are looking for a point where you should cut resonances, always do it in a cut mode. This is really, really difficult. It took me years, again, to learn that, and it's always good to start searching in boost mode. When you find the frequency that you think that it's right, go into cut and sweep a little bit more. In 90% of cases, you will hear that the frequency you have chosen, it's not the right one. It will be several hertz on the left or several hertz on the right. You may find the right spectrum, but not the right frequency. It also demands precise speakers. The more precise the notch that you are using, the more precise speakers you need to hear this. Okay, so if we do get practical, if I boost this, so you can hear that I actually cut it around 60 Hertz because there was too much energy, in my opinion, in that area. Same if you go to the next band. I cleaned the resonant frequency in the bass, which is not in the scale, in the key of the actual song, and I removed some energy here. After that, low mid resonance at 200 Hertz, and another one, you can hear it that it's on vocal, and I removed it. With removing those frequencies, I also removed the energy from the upper harmonics, so my mid-range and my high range will appear brighter and more clear, because I removed the fundamentals. So if we just go into a bypass mode, this is the problem now because we cannot hear it. I will show it later. So then I go into side mode, and first thing that I use is high-pass filter. Can you hear any difference? There is almost no difference between high pass and low pass, even though the frequency is pretty high. You can hear it now. Okay? So you can easily cut everything below 150 Hertz in this case without any side effects. Why is this important, especially with techno and electronica?
Preserving space for low frequencies.
Okay, but to which medium? To which medium all records were made, especially club records? Vinyl. How is audio written on vinyl? Lateral and vertical movement.
Mid and side.
Mid and side. So what happens if we have soup on side?
The needle skips.
The needle goes out of the groove.
Yeah.
So this is called elliptical filter. The first thing cutting engineer will do will grab elliptical filter when he is cutting vinyl. And he will cut all the bass in the stereo portion. Another thing is that, what do we know? Is the bass unidirectional or omnidirectional?
Omnidirectional.
Omni. So why would we have bass in stereo if it's omnidirectional anyway? So if we are cutting the low end in the side channel, we are saving energy for other stereo sounds, and we are also removing lower frequencies, so the higher harmonics will be much more clear. And if we reduce the bass in the side, we can increase the side if we want to achieve more stereo without actually consuming any additional energy. We actually save stuff there and we just boost it later. So this is normal. Transfer consoles for vinyl, or for example Maselec mastering console has elliptical filter built in. And you can buy separate devices which are just elliptical filters. And it's nothing else than a high-pass filter that is working only on the side portion of the channel. So again, the next thing, the next process will be cleaning of frequencies that are not needed in the side channel. Again, resonances in the stereo field, it's difficult to hear them here because it's not such a controlled environment, but you will hear the difference afterwards when I will bypass the whole EQ. And I have anything else, and then the next thing is I boosted the side with the help of high frequency shelving EQ, meaning that I increased the level of the side channel for, in this case, 3 dBs, and therefore enhanced the stereo of a song. Why am I using shelving EQ instead of this stereo width control, which does exactly the same? Is because I can control the frequency from which the stereo enhancement starts. Because sometimes you don't want low mid to be enhanced in stereo because weird stuff will start to happen and stereo picture will collapse. Sometimes you want to enhance just the upper range. So therefore I use shelving EQ, which is usually set really, really low and it's just functioning as a normal gain. But if I want to, I can define a specific frequency range in which I will boost the frequency range. Same goes if I would be boosting a separate band. Sometimes it will happen that I will boost a narrow band in the mid side to put the vocal a little bit up front, or sometimes I will boost some frequencies in the side for whatever reason. Okay, so this is basically the whole process. This is the original mix. I don't know how much difference you hear there. This is the original. This is the master. It's wider and it has better groove. The point is that the difference is really, really subtle. And this is the basic idea. I mean, you may not hear it here. I completely understand that. The steps in mastering have really subtle changes, and it's really difficult to hear what actually changed in this process, what will change in the next one. But when you chain 5, 6 or 7 small processes, the difference between the original and the final master will be big.